Hi, my name is Ebba Fomi, and today I will be presenting my multi-user events locator application. It is a full-stack backend system built with Node.js that helps users discover events based on their location and preferences. So this application demonstrates advanced backend development, including geospatial data handling, asynchronous task processing, and comprehensive testing. The project was built with Node.js, with Express.js for backend framework, PostgreSQL and PostGIS for extension and geospatial data. IL8 next for multilingual support, just for comprehensive unit testing, bcrypt for 12 sorts rounds for secure process password hashtag, and JWT for stateless authentication. As you can see, my project is already running, but I'm just restarting it just in case. While it's restarting, I'm going to take you through the user management. So we'll go to the controllers and the auth controller file. So basically, the application implements secure user registration and authentication. The registration endpoints would accept email and password only, and additional user preferences like location and categories are set separately through the user profile update endpoint. Um, Let me show you how the password was done. That would be in details. Password. Okay. So the passwords are hashed using bcrypt with a salt factor of 12 before storage, and this would provide strong security against brute force attacks. Um, The login system uses JWT for stateless authentication, and users receive a token upon successful login that must be included in the authorization header for protected users. I'm just going to show you how, because I have already tested the endpoints. So as you can see, this is the registration endpoints, and once the user puts in all their files, once the user imputes all their files, it's supposed to run and everything's supposed to go correctly. And when they update their category preferences, they will use the profile updates endpoint, as you can see here. Um, so let me go back to my file models. So users can set their home location using latitude and longitude coordinates and select preferred event categories and choose their interface language. So this information would enable personalized event recommendations. The database schema is fully normalized with separate tables for users, events, and categories, and junction tables for many-to-many relationships. And the events table stores latitude and longitude as double precision columns. Then it would create a spatial index on the computed geography points for efficient queries. Uh, as you can see in the events file in the models folder, the events this is basically the event model definition. So as you can see, I when I was writing the code for this, I made sure that the latitude and longitude were as separate columns, which would make them easy to work with in code. When it comes to the event creation endpoint, it accepts event details including title, description, location coordinates, datetime, and a single category ID. So this is what is seen after a user has created their event. Basically, as you can see, the ID is there, the title, latitude and longitude, category ID, and basically everything important. So the application supports full CRUD operations. And if we go to the event routes file, which is in routes folder, the validation middleware ensures that all required fields are present and correctly formatted before the controller processes the request. Only authenticated users can create events, and only event creators can modify or delete their own events. So one of the core features is the location-based search using PostGIS spatial functions. So the search endpoint uses PostGIS functions to find events within a specified radius of the user's location. STW within performs efficient geographical distance calculations on the Earth's surface. As you can see, this is the tested endpoints for the search feature. The API returns all matching events sorted by distance from the search point. Users can also filter by a specific category. Oh, okay, sorry. Users can also filter by a specific category, and the query parameter is category ID, which means it's singular. Okay, as you can as you can see here, this is the for events with categories. Uh, this returns only technology events. So for performance optimization, I created a gist spatial index on the computed geography expression, which dramatically speeds up distance queries even with thousands of events. So now we can talk about the multilingual support. The application supports multiple languages using IL8 Next. Here is the IL8 Next initialization with file system backup with file system backend configuration for loading translation files. I've implemented support for English and Spanish. Translation files are organized by namespace and contain all UI strings, error messages, and validation messages. So this is for Spanish, and then this is for English. Feel free to go back and compare. Um, so the language detection middleware reads the user's preferred language from the accept language header or from their user profile, and then loads the appropriate translations. So this makes the application accessible to global multilingual audience. For asynchronous task handling, I implemented a notification system using Redis with the Bull queue library. When events are created or users update their preferences, the system queues notification jobs. A background worker processes jobs from the queue, and the worker runs independently of the API server, ensuring notifications are sent even during high traffic. The worker um the worker queries upcoming events and matches them with users based on category preferences, users who follow that event category, location preferences, which means user within a reasonable distance, and timing, only events happening in the near future. I also implemented a delay calculation to send notifications 24 hours before events start. I've also achieved strong test coverage across all modules. The test suite includes integration tests, unit tests, and service layer tests. So here are the integration tests that cover the full API flow, which is user registration, login, event creation, location-based search, and more. The notification system has dedicated unit tests that verify job creation and queuing, delay calculation, user matching logic, and retry behavior. Uh, the timing calculation tests ensure notifications are scheduled correctly across different time zones and edge cases.